So by this point, we should be pretty comfortable with solving systems with two equations, both algebraically, by elimination, and even graphically. Now, it is possible to do this with three equations. We can do this algebraically, and later on we'll do it with matrices. So this is just kind of to get you started with it, just because it can be a lot to take in just in one class period. So this will kind of give you an introduction. We'll do some more examples in class, and then we'll go from there. So with lines, we know that lines can either intersect at one point, like this, no points, so they're parallel, or they can be intersecting in infinitely many places where they coincide. They are one line. Now, when we are talking about three variables, we're talking about planes. So we could intersect in exactly one solution, infinitely many solutions, no solutions, and so we're pretty much looking at the same types of solutions we saw with lines, except it looks different. It's going to be a point, it's going to be a line, and this diagram is from page 178 in your textbook. So let's take a look at our process and how we do this. Step 1. Take two of the equations and eliminate one of the variables using the elimination method. Do this a second time with the third equation and with either of the first two. Now make sure we get it into the same two variables. Because if you solved for x and y in one set of equations and then y and z in another two, you haven't really helped yourself anywhere. Secondly, we're solving the new system for both of its variables. And final step, substitute the values found in step 2 into one of the original equations and solve the remaining variable. Sometimes this will be a long process that takes up lots of room on your page, and sometimes you'll be done quick and easy. So let's look at three examples, and like I said, we will do more in class. So example 1, we have 4x plus 2y plus 3z equals 1, 2x minus 3y plus 5z equals negative 14, and 6x minus y plus 4z equals negative 1. Now, in order to keep these straight, I like to label them with letters. So I label the first one A, second one B, third one C. Some people like to label them with numbers, but I find that sometimes, well, equation 1, and then I just mix up my numbers. So I, keep it easy with A, B, and C. Now you're looking for which one of these equations you want to kind of manipulate. Which one has a nice coefficient that works well with the other two equations. And I see here I've got a 2, which works pretty well with 4 and 6. So I'm going to go with that. I'm going to go with B as kind of my manipulator. So I'm going to work with equation A. So I'll rewrite it as 4x plus 2y plus 3z equals 1. And in order for those x's to go away, I'm going to multiply b by negative 2. So I'll get negative 4x plus 6y minus 10z equals 28. You've got to be really almost painstakingly slow so you don't make a mistake early, which then makes you redo everything in the end. So let's add. 4x minus 4x is 0, so those drop out, just as we intended. 2y plus 6y is 8y. 3z minus 10z is negative 7z equals 29. Now I need to use equation B to get rid of that x variable again, but in this time in equation C. So I'm going to rewrite my equation C. And then this time, in order to get rid of the 6, I'm going to multiply by negative 3 for my B. Once again, we are adding. 6x minus 6x is 0, so those drop out as we intended. Negative y plus 9y is 8y. 4z minus 15z is negative 11z. And then negative 1 plus 42 is 41. Now I have two equations that are both in y and z. I'm now looking at these to see which variable can I eliminate. And I see right off the bat, they both have an 8 coefficient for our y's. So let's multiply one of them by negative 1. And I'm just going to do that with that first equation that I got. So negative 8y plus 7z equals negative 29. And then we have 8y minus 11z equals 41. Now we're looking to add these again. So we've got 7z minus 11z, negative 4z equals negative 29 plus 41. We have 12 there. Divide by negative 4. Z equals negative 3. Now we need to find out what y is. So we can't just plug it into our original because there's still another variable in there that we don't know anything about. So let's plug it into one of these equations. Let's plug it in here maybe. So I've got 8y minus 11 times negative 3 equals 41. 8y plus 33 equals 41. Subtract 33 from both sides. 8y equals 8. Y equals 1. So far I've got two of my variables. Now we can plug it into one of our original equations. And we can pick any one we wish. So let's plug it into, I don't know, let's plug it into b. So I've got 2x minus 3 times y value of 1 plus 5 times z value of negative 3 equals negative 14. So I've got 2x minus 3 minus 15 equals negative 14. Let's add over the 18. So 2x equals 4 divided by 2. X equals 2. So as a final ordered triple, we have 2, 1, negative 3. Just as with lines, we could plug our coordinate in for both equations. We are able to do so with our ordered triple. We can plug it into any of these equations, and if our answer is sound, it will end up being absolutely correct. Let's look at another example. So as we see, it can take a bit of work, and you have to be careful. Okay. We have three more equations here, so I'm looking for the one that will most easily be the one that I can call the manipulator. Which one has the best coefficient that I can work with? And I see again, I've got a positive 1 coefficient on that x in that first equation this time, so I'm going to use a. So I'll work with a and b first. So I'll rewrite my b, since I know I'm not going to have to do anything with that one by design. And then to get rid of that x coefficient, so that 3, I'm going to multiply equation a by negative 3. Now, we're adding again. So we've got 3x minus 3x, 0. 3y minus 3y is 0. And then negative 3z plus 3z is also 0. So we end up with 0 on one side, and then 8 minus 6 is 2. Well, we've got to ask ourselves, is this true or is this false? In this case, it's false. So in one step, really, we found that this has no solution. This is one of those planes that, there's three different ways they can intersect pairwise, but with all three of them, there's nowhere that all three have the same solution. So luckily, that's quick and easy. Let's look at another one. So again, I see, well, maybe I can get rid of my y's this time, since equation b has a negative 1 coefficient, but equation a and c both have a positive 1. So maybe that'll be an easy one to get rid of. So I'll go with a and b first. Again, using b as kind of my manipulator, my middleman. So x plus y add them. So x plus x is 2x, y minus y is 0, as we intended, and then z plus z is 2z. Now you gotta be careful because we make sure that we're consistent with our systems. You know, if you go between adding and subtracting them, you may see the x and x and simplify that down to 0, which will throw off your solving of your system. So just be careful. Okay, so we're down to two variables. We're down to x and z. So let's use that equation b again to get rid of the y again. So we've got x minus y plus z equals 6. That look like a 6 a little bit more. Add them. And now I see I have both equations, and they are both in terms of x and z. So now I've got to determine, well, I've got to solve for x and z now. So I see there's not going to be a 1 multiplication that's going to get me to the same coefficient. So I'm going to have to multiply one of them by, let's do -5, and multiply the other one by 2. So I'll bring this one down first. And then bring that one over. And once again, we are adding. So -10x plus 10x, 0. -10z plus 10z, 0. -60 plus 60 is also 0. So now we're to a point, well, we see 0 equals 0. We know that is true, so this is our identity. This doesn't mean that every number we plug in will work, but there are infinitely many solutions. So, in the cases of infinitely many solutions and no solutions, it can be pretty quick. However, and as we'll see in most cases, if we are doing it by hand with 3 equations and we have an actual ordered triple, it can take a little bit. As I can't stress enough, you must be really careful to make sure that you don't make a mistake early on, so that way when you go back and check that your answer is correct, you notice that it's not, and you've got to start all over. Now this all should serve as a nice foundation for more time in class where we can solve more systems of 3 equations and then kind of just go beyond this and do some problem solving with this. Try not to feel too overwhelmed, though we will have to do some of these by hand. We will learn a quicker method that I believe all of you will prefer to this. So I hope this found you well, and have a great day.